we're going to talk about AI, and we're going to talk in particular about a frontier of AI agents that I think is particularly poised to have a lot of impact. And maybe you're an individual contributor, maybe you're a manager or a leader, or you're imagining things, or you're a policymaker. There are so many different applications of these kinds of technologies if we can get them to work, which they're increasingly showing a promise of. So we're going to talk through what is this frontier and what's going on. When we make decisions, we make those decisions based on what I would view as often incomplete information about how people are going to react. Maybe you're at an organization, whether it's a for-profit or a nonprofit, that's trying to decide if we do this, maybe our clients or customers will react this way, or maybe these people who aren't currently our customers will or won't react that way. Or maybe I'm a leader and I want to say, if I change my management style in this way or reorg in the following way, maybe the organization will do better or worse. We make these decisions based on the best data we can. But that data is often incomplete. And this kind of incomplete information means that we often make bad bets. And what I mean by that is that we make the best guess we can, we take all the information we can, but we're ultimately wrong. And this is not necessarily a problem with you. It's not that you're not smart. It's just really hard. We can't know in advance always what's going to happen because we have limited ability to get feedback. We can only launch once. And so we make these big bets and they misfire across these areas, across like consumer packaged goods, CPG, personal finance, product design, policy, management. Even me as a professor, I do this all the time. I'm making guesses about what's going to work with my students and not. And you think, oh, this is like a problem of of modernity and so on. But this is not even a new question. This is a thing that goes all the way back to 1906. Here's Robert Merton, a famous sociologist, who pointed out even back then, over 100 years ago, how hard it is to design for what a group of people will do. Like we all sort of want to get out of the city so that we can avoid the crowds, but then everyone wants to get out of the city and go on vacation at the same time. So we all wind up in the same forest, and it's too crowded there too. So we're very challenged in making these kinds of decisions. And I want to ask today, what if you had a what-if machine? What if you had a what-if machine? What would you use that for? If you could sort of imagine in advance what might happen. Imagine that you could say, if my organization took this path, how might our customers react? Or if you could say, if we were to fail, or if something were to go wrong, what's the pathway through which that would maybe happen? Or you could say, well, what if we could see how people might react to this policy change or this new product or this strategy we're thinking about before we deploy it? If you had this kind of what-if machine, my claim is that we could make better decisions more often, much more often. And so this has led to a kind of a really interesting question for me as a researcher in computer science. Could we create simulated AI agents that replicate human behavior? Could we create AI simulations that behave like people do? Maybe like your organization would, or like your customers would, and so on. If we could, then maybe some of these things become possible. Now, simulation isn't a new idea either, right? It goes all the way back to 1978. Here's Thomas Schelling won a Nobel Prize in economics for generating this idea of what are called agent-based models. And these things are still in use today. And I'm showing a screenshot here of a recent model that was run on like supercomputers trying to understand, if we engage in the following kind of intervention, does this reduce the kind of spread of a pandemic and so on? There are these very simple algorithmic models of people, well, actually increasingly complex, but still fairly mathematical. But simulation is not just a thing that we use in policymaking. Here's entertainment. I bet a bunch of you have played The Sims. It is one of the singularly most popular video games of all time. These are also simulations of people. And increasingly, if we are deploying AIs into worlds where the AIs need to interact with us, some people talk about AI teammates. What does that even mean? Like an AI that's on your team at work would need to start reasoning about how you might respond if it takes a certain action. And more broadly, to create a set of tools that are what I would term look before you launch. And I think we struggle with this. For much of my career, I worked in the design of online platforms, social media, these kinds of things. And many issues would come up because we couldn't effectively foresee what was going to go wrong. And so this creates the opportunity to create tools that say, what kinds of policy changes or rules do I need to set up before I launch the system so that it doesn't all become a dumpster fire, and then I set the rules afterwards. Now, the problem has been that up till today, our models have been pretty rigid. That is to say, you kind of have two options. One, you say, a human is 5 parameters. That seems like it's not quite true. We can't quite be reduced to 5 parameters. They can explain a lot about us, but I'm at least 7 parameters. It's essentially this is just much too of a sparse model to encode the richness of human behavior. The other option is to do what The Sims does, where you basically write scripts and say, if I get punched, then I fall down and I get mad. And there, again, it's sort of limited to only the kinds of things we can think to create. And it's always going to be incomplete. So as a result, at least within the academic literature, the basic conclusion is, I'm going to quote here, the models have been highly stylized and have had minimal impact. So not a good track record. They're really interesting, but in practice, we haven't seen them taken up in many cases. And I'm sure some of you in this call have used agent-based models, but the vast majority of people who I talk to have not. But starting a few years ago, my colleagues and I recognized that modern AI models, so-called large language models like ChatGPT, Claude, Qwen, Llama, all of these, DeepSeek, have trained on a variety of human behaviors, which is to say that they've literally read the book on all the research about how people behave because they trained on research. And they've also trained on a bunch of social media data. They've seen the good, the bad, and the ugly of human behavior. And so as a result, what we recognized was that you can prompt these large language models to take on the perspectives of a bunch of different people with different backgrounds, experiences, and traits. So we could take ChatGPT or another large language model, LLM. We can give it a prompt that roughly equates to, be this person, here's a name, a description, and in this situation, how would they react? And by multiplexing those descriptions, we can create an entire crowd of different people. And if we create a crowd of people, you can sort of put them in many different situations and see what might happen. And in fact, we started doing this. And in some work that, shall we say, went a bit viral, we created almost like a little terrarium of many of these these AI agents that are simulated people. We call them generative agents, and we created a little town called Smallville. This town is full of 25 generative agents. These 25 agents, as I would describe them, are essentially all completely autonomous AIs that are each sort of playing the part of a different person. So you can see the entire town is going about their day. The artist in the town gets up and paints. The college students in the town, they sleep in more, and then they go to classes and do their homework and so on. This allows us to create a space where we can sort of visualize what it would mean to have these simulations of human behavior in a way that we can learn about people and interventions. So in fact, this work got a lot of attention, and more recently, Andreessen Horowitz, I think this was just last month, put out some research, their own research, arguing that this is going to become the next sort of essentially generation of market research tools. And if you go check out this, it was in June, excuse me. If you check out this article, then they cite our research quite centrally. So what I'm about to show you in this webinar is that AI simulation can create both believable and accurate simulations of human behavior. I'm going to give you a how-to guide of the techniques that enable this kind of simulation. I'm going to give you the gotchas, the things that often people get wrong that you should look out for when doing this. And I'm going to talk about the current frontiers of this technology, like what's kind of on the edge of just becoming possible. So I hope that sounds good. If you're excited, I don't know, give a thumbs up in Slack or excuse me, in Zoom, and we'll dive in. The basic way we're going to go after this is we're going to create an agent by, first we paid an online artist to get a bunch of pixel art of different characters, which you can see on the left. And these visualizations are there mostly to help you sort of see what's going on. You don't actually have to build a little video game environment like I did. I'm just a child of, I was born in the 80s, grew up in the 90s with 1990s Super Nintendo JRPGs. So it's just a cool way to show it. But essentially what we do is we create a little persona for each individual. So here's John Lynn. He's a pharmacy shopkeeper. We tell him that he runs the pharmacy in this town, and we describe who he is. He's very helpful, and we tell that agent what it knows about others in the simulation. So we tell him he's married to this other agent in the simulation, May Lynn, and they have a son, Eddie Lynn, who's a college student studying music theory. Now, we have to tell the agent about all of the other agents it knows in this environment, because if we don't, the agent's going to wake up in a bed next to May Lynn at the beginning of the simulation and go, right? It won't know, it literally will not know that other person. We have to tell that agent everything that it needs to know at the beginning. Now, what I want to try to explain to you is, over the course of this webinar, the important pieces of what it takes to build one of these. I don't expect that you understand this figure yet as I'm first showing it, but I'm going to build up to this figure over the next few minutes so that you understand what it is that allows these agents to do what they do, and so that you can create them yourselves. Now, basically, what we can do is we just describe the agents, and we're going to just let them go from there. They wake up without us telling them exactly what to do. We just describe who they are. They'll wake up, brush teeth, take a shower, cook breakfast, catch up and talk to each other. They'll pack and get ready. And what I'm going to do here is, to the Global Alumni team, I can message you, but I can't message the people here. I just sent you, to the Global Alumni team, a link to a demo. If you can echo that demo link out to the group, they can actually load it up and see the town in sort of effectively real time. So I encourage you to go check it out. Thank you. Yes, you sent out the correct thing. So please go check out that link. Now, the agents then act in the environment, because these are just AI agents, right? Which means they mostly just act in the sense of they use natural language. So they say, this agent, Isabella Rodriguez, is drinking coffee, right? We then need to ground that text into concrete movements in our little video game environment. So we say, they're drinking coffee. Okay, they're going to walk over to this chair, and then we're going to render a little emoji that summarizes what it is that they're doing. So if you go and clicked on that demo, you can see the agents are often having these little emoji bubbles that show what they're up to. So we ground their actions, which start out as language, into this game environment. But you can talk to these agents. Literally, you can sort of intervene and talk to them. So if you pretend to be a newspaper reporter, then you can say, hey, who's running for office? Who's running for mayor? And if the agent knows, they'll respond, oh yeah, I heard Sam's running for mayor. And if you want to control these agents, then you can just pretend to be their inner voice and say, John, you're running for mayor. And then John says, well, I really need to talk to my family about this big decision that I'm considering. So you can also intervene in the game world. I can take the toaster, set it on fire, and the agent will recognize what's going on and run over to put out the fire and then go make something else for breakfast, right? So we have all of these opportunities to sort of think about interventions in the world and how agents might respond to them. Now imagine intervening and changing the layout of the home, or the kinds of information they have access to, or the kinds of products in their home, and so on. So just to give you a sense of what this is actually like, let me take it from here. These agents talk to each other, right? They're language agents. They're AI agents that can talk. So in the morning, John sees his son, Eddie, and engages in conversation. Says, hey, good morning, son. Did you sleep well? The son says, yeah, I slept great. He says, hey, what are you doing today? And the son says, yeah, I'm working on this music theory composition for my class. Remember, he's a college student. He's a music theory student. So he's working on a composition, a new song. Now, John doesn't know this, but now he does. He has to remember it, because soon in the simulation, Eddie's going to leave the house and John's wife is going to wake up and say, "Where's your son?" And John has to remember what he learned so that he can tell her, yeah, he left, he's working on this music theory composition. And now she knows, and this is how information can sort of spread through the environment. Now that's a simple example. But we wanted to examine a much more complex one. So here's what we did. We initialized Isabella, this agent who runs the cafe in town, with a simple intent to plan a Valentine's Day party. So the simulation starts on February 13th, the day before Valentine's Day in the morning, and it runs through the end of the 14th. So we just inserted into her memory this little intent that she was interested in planning a Valentine's Day party. And what I want to convey to you is that nothing about this AI agent architecture that we're talking about today is like a party planning module. Nothing that says, oh, this will definitely work. And in fact, there's a lot of reasons why this might fail. This agent has to remember to tell the other agents about the party. Anyone who's told about it needs to remember that invitation. And those who remember it have to actually show up. And yet, from this seed, we start to see evidence of classic information diffusion patterns, which you might think of as like sort of rumor networks, whisper networks, just word of mouth. So Isabella tells people, people tell other people. You can see this graph of who's hearing about this party from whom as the simulation plays out. And in fact, Isabella goes and gets her friend Maria to help decorate the cafe in preparation for the party. Again, we didn't tell her to do any of this. This agent decided to go get help from the other agent. At the end of that day, like the next day, on Valentine's Day, half the town had heard about the Valentine's Day party. So of the 25 agents in the town, 12 of them heard about the Valentine's Day party. Of those 12, 5 came to the party. 3 said they were busy, and 4 said they were interested, but ultimately didn't show up. So is this accurate? It's a little bit of an interesting question. It reads to me as broadly plausible, but it's not necessarily easy to tell. Is this exactly how it would play if this were real life? It does, to me, seem like a pretty compelling evidence of the kinds of believable behaviors you might get. And in fact, one more kicker on this. We not only told Isabella she was interested in planning a party, we planted a memory in the Maria agent, that ML that you see on the left in the image, that she had a crush on Klaus, another agent. And it turns out that Maria asked her crush to the party. So we had a little nascent agent love here. So very beautiful. And in fact, researchers who are not us got this whole simulation running again just this year and found that they could intervene and study different alternatives. So now they said, oh, okay, what would happen if suddenly some of the agents heard on the radio that there was a new communicable disease, like a new epidemic of swine flu. And you can see in that pathway when they ran the simulation, oh, no one showed up to the party except for poor Klaus. Klaus had not heard about the new illness, and so he showed up anyway. In the no threat condition, the party happens as usual. And when the agents hear a radio about a non-infectious disease like diabetes complications or something like this, the party also happens as normal. So you can think about how interventions into the world let you ask these what-if questions that can be quite powerful. So how do we do this? I'm coming back to this image, and I want to try to explain the major parts of this architecture. You don't have to be technical to understand this. I want to convey the main pieces. The first thing we need to do to create an agent like this is we need to give them the ability to remember. So we give them what's called a memory stream. This memory stream is essentially a blow by blow record of everything that the agent observes. So you can see a lot of this is actually not very interesting. They see a bed, they see a desk, they see a closet. Some of it is more interesting, like, I'm stretching, I'm writing in my journal, I'm taking a break, I'm cleaning the kitchen, and so on. But there's a lot of stuff here. You could fit it into the context of some of the larger large language models, but these models, the research suggests, can get distracted with very, very long contexts. So we actually do something that's referred to in the literature these days as RAG, or retrieval augmented generation. So with RAG, what we're doing is we're preferentially retrieving memories that were accessed recently, that are important to the agent and that are relevant to the current circumstance. So recency means if it's something that you observed recently or that you recalled recently, that's more likely to come up. If it's important, like the fact, the agent brushes its teeth, not very important to the agent. The fact that it got asked out to a party, pretty important. And finally, relevance. So if an agent is taking a math test, then other memories about taking tests or about that math class should be top of mind. So it's almost like running a little bit of a Google search over all of these memories. And so now what happens is what you can see on the right. If we ask the agent the question, what are you looking forward to right now? We're going to retrieve these recent, important, and relevant memories, like things like that they're planning a party, that they're ordering decorations for the party and researching ideas for the party, put those into the context window of the large language model, along with the description of Isabella herself. And that's what gets Isabella to reply in a reasonable way, saying, I'm looking forward to this Valentine's Day party. Memory, the first thing you need. The second thing that we feel is important is this ability to reflect. If you have a psychology background, then you might be familiar with what I'm about to say, where the memory I just showed is what's called a purely episodic memory. It's just like a log of what happens. But if you think about it, we're more than just captain's log. This is what happened. This is what happened. We needed to provide the agents with the ability to produce higher level reflections of who they are, what they like, their dispositions and their interests and their goals. So what we do is we essentially get these agents to have shower thoughts, figuratively speaking. So what we do is at regular intervals, we pull memories from the agent's memory stream, and we ask the agent to reflect on those memories. Here's two examples to produce a higher level reflection or conclusion about them. So given the two observations that Klaus Mueller is reading about gentrification, reading about urban design, we produce a reflection that Klaus spends a lot of time reading. And we can do this over and over again by continuing to group memories and reinserting those reflections back into the memory stream to produce higher and higher level reflections about who this agent is and what their goals are. This produces the ability for the agent to essentially produce behavior that's much more consistent with these goals rather than just literally being a robot and walking from step to step. The third thing is planning. So planning is important for these agents to remain believable over long periods of time. And planning is something that is not unique to this project. It's been a long time issue with AI. So what we would do is we would start by having these agents plan out their full day. Then we would drill in, and given that day, say hour by hour, what are you going to do? Then we're going to drill in again and go minute by minute and say, okay, in details, what are you doing? And when the agent sees something as they're acting in the environment, like here, the John agent might see Eddie, his son, taking a walk around his workplace, then we will ask this agent, given its background, and you can see the prompt here on the left, if it should react to the observation. If so, what would be an appropriate reaction? And then replan if we need to. So this is how the agents adapt as the simulation runs. Now, this work got a lot of attention. It really caught fire with a number of people. And it was really interesting to see. And I think I just want to start by suggesting, like, there's some evidence that there's something to this idea that of the goal of creating these simulations of people and what that might enable. You can see here news reports that are featuring Jun Sung Park, my PhD student who led this work. And yet, with this vision, I haven't fully answered the question, right? I asked this question before about whether we can create simulated AI agents that replicate human behavior. Everything I've showed so far shows believability, but Disney characters are believable, cartoons are believable, but they may not be accurate. And if you're going to make decisions based on this, then there's this question of how accurate are these agents at replicating behavior? And that's an empirical question that we really need to ground out if you're going to think about whether you want to be using this. So how do we measure this? Because there's papers out there that just try to replicate this study or that study and say this one works or that one doesn't, but others then try to replicate that and show a different result. How do we act? How do you actually know? So let's talk through how you might know. Well, there's a few different ways you could go about this. One thing you could do is build what you might call demographic agents. So here you take sort of a sample of the population and you produce a demographic agent version of a person. So here's a demographic agent version of me. It says, my age, where I live, my job, and these kinds of things. On another hand, you could create what we did in that Smallville simulation, these persona agents that are sort of more narrative descriptions of the person. So again, on the right here is a persona agent version of me. So it, maybe adds a little bit more flavor, but also misses some information. But they're both interesting. The issue here, as prior research has demonstrated, is that both of these approaches can produce very simplified and stereotyped behaviors. Most kind of one of the instances that was most striking to me was that if June Park, again, my PhD student or now alum who started this work, if you just produce, he's from South Korea, and if you tell the model that and say what is he going to have for lunch, the model says rice. Not great, really. Probably not accurate either. It's very stereotyped. It has bias, all these kinds of things in it. So what are we supposed to do? So what we found is that there are better ways to do this. In particular, we found that rich qualitative information is an interesting direction. So what we did, and this is some more recent research, is we went out and ran 2-hour interviews with a representative sample of 1,000 Americans. Now, obviously, this is focused in the US, but you can do this yourself in your local jurisdiction if you're interested. So we would run these long interviews, and I'll talk about whether 2 hours is necessary later. It turns out, actually, you don't need 2 hours. We took an interview script from a project here at Stanford called the American Voices Project, led by David Grusky. He's a sociologist, has this very broad-ranging interview script that literally starts with the question, tell me the story of your life. And then it covers everything from their communities and their jobs and their finances and their health to their politics. It's just this broad backbone of who they are. We use this 2-hour interview to construct a digital twin of that same person, a generative agent of that same person, with that interview as the memory of the agent. Okay, so now we have a real person, 1,000 real people, and 1,000 twinned agents for them. That real person then takes a large battery of surveys and experiments so we can gauge what their actual attitudes and behavior are in realistic scenarios. So here I'm going to focus on the general social survey. This is a 170-ish question survey that has been fielded in the United States over the last 50 years. But we also look at the Big Five personality index, some behavioral economic games, some replications of experiments. This broad battery. We then have the generative agent of that same person take the same surveys and experiments. And then now we can finally measure this more accurately. We can say, how closely does this person's agent replicate that person's actual behavior and attitudes? I hope that makes sense. So we have real person, agent version of them, and we ask how well the agent version of them replicates their exact answers. So we run these interviews actually with another AI agent. It's a voice-to-voice interview, like a phone interview. It's on the computer, but it's I've changed many of the details here to preserve anonymity. But I just want to give a sense of the flavor of the kind of information that these interviews yield about people. Obviously, this data all remains private for human subjects reasons, but you can see that the kinds of things we're learning are people's backgrounds and their life stories, their ambivalence toward political identification, what their jobs are and were, their finances and how much extra money they have to spend on various categories and so on. So it's just a very, very rich background. All we do then, and if you wanted to create these kinds of agents yourself, given this kind of interview, is we put the interview up at the top of the prompt to ChatGPT or another model, and we tell the model, based on this interview transcript, I'd like you to predict how this person would respond to the following survey or experiment. Now, there's more detail to it here. You can see the actual prompt we use, but for the most part, it's just the yellow parts here. Interview, and then now please predict what this person will say in response. What we find is that these agents do accurately replicate attitudes and behavior. Now, in order to explain this, we need to say one more thing about the method. It turns out that if I give you a survey today, and then I give you the same survey 2 weeks later, you are not going to answer exactly the same thing. A lot of stuff's going to be the same, but not exactly the same. So we need to normalize for this. So we do exactly this. We have everyone, all 1,000 people in this experiment, run the same survey twice. And so what we're going to do here is every result I'm going to show you here is going to be sort of a ratio, where 1.0 means that agents replicate people's responses as accurately as people replicate themselves 2 weeks later. I hope that makes sense. So like a 0.1 would mean we can replicate people's responses 10% as well, as accurately as people replicate themselves 2 weeks later. Okay, so if you were to do this, if you were to guess randomly on this big survey, you can replicate people about a third as well as they replicate themselves 2 weeks later. That's a baseline of sort of how predictable people are. If you use these persona agents or the demographic agents, you can replicate people about 70% as well as they replicate themselves 2 weeks later. And if you use these full interviews like I was describing, you can replicate people 85% as well as they replicate themselves 2 weeks later on the general social survey. I think that's pretty impressive. Now, it's not just the general social survey. Across a series of other tasks, like the Big Five personality index, behavioral economic games, you can see that these normalized coefficients are all generally in this similar range. So we think that there's substantial possibility here. Furthermore, actually these interviews reduce bias. And if you have this full interview, if all I know about you is that you're like a Republican, a conservative, then it really stereotypes. But if I know a lot more, then the model can get much more subtle. So it turns out across these different approaches that you might imagine, politics is the hardest to model. So the difference between the best performing group and the worst performing group was around 8% accuracy, normalized accuracy. The worst performing group for us was far right conservatives. The underlying language models are pretty unhappy responding to questions as a far right conservative. They've been value aligned maybe to not say some of these things. And the far right conservatives themselves in the interviews were a little more coy about their true opinions. Gender and race surprised me. They had smaller gaps at a baseline than I expected. But again, the interviews cut out a lot of the difference. So again, we're looking at maybe just a sub, in the case of gender, sub 1% difference in accuracy between the different groups. In fact, as I mentioned, we also had 1,000 people do this. We had 1,000 people replicate experiments that were published in top tier journals, the Proceedings of the National Academy of Sciences. This is top tier science. So we had 1,000 people replicate those same studies, and we had their agents replicate those same 5 studies. Of those 5 studies, our agents replicated 4 of the 5. And you might say, oh, well, that's not great. You missed one of them. But it turns out that we didn't. The 1,000 real people also didn't replicate that 5th study. That 5th study was actually bad science that didn't replicate. That result with real people that was published wasn't a real effect. And the simulations correctly predicted that was going to happen, that 5th study wasn't going to happen. And in fact, my colleague here at Stanford, Rob Willer, has generalized this in a really compelling way, where they found a bunch of non-public study results that were pre-registered. So they got all of these studies, 100,000 people, and found that they could predict the effect sizes of these experiments with simulation with a correlation between 0.85 and 0.9 pretty strongly. Now, what this wound up with for us was this agent bank of 1,000 consented participants from the United States. So we have this agent bank that we can now use to sort of test maybe depolarization or climate change kinds of questions and so on. But if you're trying to do this for your organization, you might want to think about who ought to be in that agent bank that you would build for questions that you care about. Should they be representative of your customers? Should they be representative of people who are not currently your customers but could be? Should maybe your company has internal marketing or user research data that you've interviewed people in the past. You just have a data set sitting there that you could turn into an agent bank. Here's my advice. Here's my how-to. A bad way to do this would be to define agents with a single demographic variable, like just be a conservative, be a Republican. This produces all sorts of stereotyping and underestimates the variance, the distribute, like it makes it seem too certain when you need it to be more uncertain. It's not enough. Not terrible would be 5 or 6 demographic variables. We saw that was able to replicate people about 70% as well as they replicated themselves 2 weeks later. Better was data as rich as you can gather, like these interviews we were finding. We were actually able to maintain very strong accuracy by having a much shorter interview. So we went in later and we just deleted random 80% of the interview, and we went from like 85% accuracy to like 79 or 0.85 replication ratio to 0.79. It didn't really decrease it that much, which surprised me, to be honest. So there's something about these interviews is teaching very rich information. But I do think and I see a comment in the chat about this exactly on point. You have the remaining parts of the interview have to be relevant. So if you're only interviewing people about their views on fashion, say, and then you're trying to predict their views on climate change, there's just not enough for the model to generalize it. Okay, maybe if we know that they're very high, high income or something like this, you might be able to extrapolate from there. The models can do quite a bit. But if I'm only interviewing you about sports teams and then I'm trying to predict your retirement planning or something like that, it makes sense that it would be that it's a little bit too disjoint. You have to make sure that the data you gather is relevant. Now, we cannot proceed without talking about the risks of this. There's literature. Not every study replicates correctly. And you can see some of the research here that has found examples of cases where this hasn't replicated. And I can show you an example of one case where this really has happened. So here's a company that I was talking to that tried to implement this. On the left is ground truth data. This is Pew Trust. And if it's a little blurry for you, then what's highlighted in red is this age, broken out by age, 18 to 35, 36 to 51, and so on. And they're asking people how familiar they are with their retirement plan fees. I want you to pay attention to the dark blue part of the bar, where, say in the 18 to 35 group, 13% of people said they were very familiar with their retirement plan fees. On the right, you can see their simulation result, where instead of 13%, that one was like 1.2%. Now you might say, oh, well, Michael, you still got the biggest one. That middle bar was still guessed to be the biggest one, and the second one was still guessed to be the second biggest one, and so on. And so maybe it doesn't matter for your particular cost, but maybe it does, right? Maybe the difference between 13% and 1.2% is the difference between we ignore this subpopulation and they're a sizable minority that we would care about. So these things can make errors. And the way that I think about this today is think about it as a ladder, where as you climb up the ladder, you take on more risk of issues, but it also gets more ambitious. So you might start out at the bottom of the ladder with a question of possibility. What might happen? What could happen? We're not going to put a probability label on it or say how likely it is to happen. Just this is an outcome that you might want to think through because it could happen. Further up would be sort of qualitatively oriented outcomes, things like attitudes, anything that is sort of chat outcomes. And this is, I think, safer because we're pretty good at modeling this already, given the interviews. Higher up, and where I just showed the error, was quantitative outcomes, like histograms, bar charts, where the difference between 5 and 10% might really matter. And at the top would be multi-agent simulation, the sort of town that I was describing, an entire market simulation. In order to trust that, you need to have a lot more assumptions. So let me dig into what you would need to see to trust each of these. Because this is a totally new method, and I want to stress that you should not over-trust such a method. With the possibility rung, this one I would say mostly generally works today. What it needs to generate is a plausible chain of events that could lead to a potential outcome. And you should be able to, just by looking at the chain of events, say, oh yeah, that seems plausible that could happen. Oh yeah, if a troll shows up in my system, they could really mess with it in the following way. We need to introduce the following safeguard. On the qualitative rung, it's mostly about attitudes. And so we need to be able to accurately estimate individual attitudes. I would say that my evidence is that this mostly works today if you have rich enough data. Now, it's not the same as running an interview, and I would never say that you should do this instead of actually engaging with the communities. But I think it is a good way to get a rough sense of what might people say in response to, say, a new policy or a new strategy or a new product. The quantitative rung requires actual measurement of quantitative accuracy. Say, can it recreate your market research surveys? In many cases, we're seeing yes, and in many cases, we're seeing that there are errors. So you need to tread carefully here. I think the way I would view this is that you ought to consider you have 100 ideas of what you might do. Use simulation to narrow it down to 5 that seem promising, and then actually A/B test the remaining 5 on real people to see what's working. With multi-agent, I don't think that we're really ready for that in decision making quite yet. If you wanted to do this, you'd have to be able to trust every individual agent to be accurate, right? If the individual agents are accurate, then when you put them together, then the emergent outcome should also be accurate. You could also take a complex systems perspective of like, oh, it's more about the phase changes. I think that's much more difficult to reason through. So multi-agent can be right, but it also can be wrong, and you don't know how to distinguish those. So I would be very careful. How do we mitigate these risks? Well, for one, make sure your agents have in-domain data in their memory. Again, this is don't interview about fashion if you're asking about retirement. Second, the possibility and the qualitative rungs reduce and mitigate many of these risks because they're what I would call rough-edged problems, where if it's 80% correct, it's still helpful. It's still helping you learn. Whereas the quantitative rung is like sharp-edged. It's either right or it's wrong. And if it's wrong, you might be making the wrong decision. And finally, validate important questions on a small subsample to make sure that the model isn't too far off. Now, I want to highlight here that there are frontiers of this space. I'll show just a couple. One is the set of tools around look before you launch. So this is actually where we started. As I mentioned, I was doing a bunch of work for many years in online platforms where people wouldn't foresee the ways that their policies would backfire. And what we did is we found that these tools are actually very useful at this possibility rung to help people fix things before they go wrong. And we would get these quotes from people being like, yeah, everything we do is set in reaction to a dumpster fire. That's really a terrible way to run a community. And in response, and instead, when we gave them access to these kinds of tools, they actually iterated in simulation. They're like, oh, I didn't realize that this low effort post would do this kind of thing. And then the troll would respond in that way. And they actually fixed it before it launched. I now actually do this every year when I teach a course in online platform design. I have students, I open the fire hose of trolls at their systems. And their goal is to make them stay upright. And I think we get better projects for it. A second application of this is training soft skills. So one that we built in collaboration with an expert in the Stanford Business School in conflict and negotiation, is these systems around conflict, negotiation. Everyone thinks that they're great at conflict until things start going wrong. And we felt, maybe these generative agents can serve as sort of like sparring partners or training partners so that you can engage in this conflict or this negotiation. Maybe you're negotiating a salary for a new job or whatever in simulation before you go and have the actual conflict. So we created a tool that let people sort of simulate a conflict. It's almost like a Monty Python, where we then ran an experiment on it, where we randomized people into either watching a lecture on the best in class strategies for handling conflict or watching that lecture and going through a simulated conflict. Both groups, critically, did equally well on a book test of what they're supposed to do in a conflict. But only the group that had the simulation did better in an actual conflict later. Having done the simulation, reduced their likelihood of using an antisocial strategy by 2/3. So there's something about this idea that I could try something sort of in simulation that really aids learning. Now, as I mentioned, there's, I think, going to be a number of business applications for this. I brought this article up. You can look at this for a fairly up-to-date assessment of what's going on if you're in market research or something like this. I will, with some embarrassment, point out that if you scroll far enough down in that article, they actually mentioned this startup that the Stanford research that I'm describing here spun out into. This the company that we're spinning out is called Simile. But there's a lot of open research in this space that I'm mostly focused on trying to share here. And what I think I want to do is just highlight that there's so much that we can learn from the opportunity to create this what if machine that allows us to really go forward and think through what might happen. I'm going to flip this over to QR code for Global Alumni, where if you want to learn more, I teach an online course